Well, good morning, and thanks for starting your day off with me and Active Directory. We're going to be talking about more things in Active Directory that can screw up your desktop and application virtualization efforts and how to fix them. But first, make sure you tweet about this. That way my wife knows I'm actually doing something in Chicago, and then my mom can think her son is actually being a productive, tax-paying member of society. My name's Webster. Everyone just calls me Webster. I'm an independent consultant based out of Nashville, Tennessee. I've been a Citrix technology professional since 2010, and I run the website carlwebster.com, otherwise known as the Accidental Citrix Admin. And you can email me, follow me on Twitter, hook up with me on Facebook, link up with me on LinkedIn. It's all pretty simple. Everything is just Carl Webster. Now, before we continue, my tradition is to always have a PDF of the presentation with all my notes, all my research, and then all the feedback from directory services MVPs and other directory services experts, because I get all of this stuff reviewed by them to make sure the information I'm giving you is up to date and accurate. Because a lot of the information you will find on the internet about the topics we're going to cover today are just downright wrong, or conflicting, or they're just, some of the stuff is just plain stupid, what some people write about what we're going to be talking about today. So everything's in the notes, so you don't, or in the PDF, so you don't have to scramble around trying to record or write down all the URLs and links and stuff like that. So last year at BriForum, we covered 10 things in Active Directory that can screw up your desktop and application virtualization efforts and how to fix them. And those 10 things were to check your domain and force functional levels, make sure all domain controllers are global catalog servers, no manually created connection objects in sites and services, check the netlogon.log file on every domain controller for missing subnets, and then create reverse DNS lookup zones for all those subnets and sites and services that were created. And then clean up DNS of unnecessary duplicate host names and IP addresses, clean up orphaned domain controllers, make sure the PDC emulator is configured properly to be the authoritative time server, and make sure all domain controllers have their DNS IP settings configured properly, and to use Microsoft's and other vendors' Active Directory design guidelines. Now, from those 10 things, I got lots of questions, and all the questions centered around two things. Hey Webster, you talked about how to do domain controller DNS IP configuration for a single domain, single site, but I've got a single domain with multiple sites. What do I do? Or I've got multiple domains with multiple sites. How should my domain controllers be configured? And then, hey Webster, I went and I configured DNS Aging and Scavenging, and none of the records were deleted. So why aren't all these old DNS records being deleted? Or some of them were pretty bad. Hey Webster, I went and did all this configuration, and it didn't look like it was working, so I found this command on Google. And the next day, almost every record in DNS was missing. What happened? Because my boss sure was pissed that I did that. So now, these are the two things we're going to be talking about today. I've been working with Active Directory for 12 years and 1 week as of today. And in that period, I have done a couple of hundred AD migrations and cleanup projects, especially for people in our virtualization world. They're either doing desktop application virtualization and they're having issues. The number one and the number two reason that Active Directory migrations fail or are greatly hindered, the number one and number two reason that desktop and application virtualization efforts either fall flat on their face or are greatly hindered in their proof of concept and pilot and rollout phases are these two. So why are we covering these? because these are the top two reasons that what we deal with in our world of virtualization, why projects fail. And we get a bad name, and Citrix or Dell, vWorkspace, View get a bad name, and it's not the product. It's the way Active Directory is configured, not configured, or misconfigured is the reason for failures. So our agenda. We're going to cover the basics of aging and scavenging. Then we're going to cover when can scavenging start. Then we're going to cover aging and scavenging for a sample record, DHCP, and then we're going to put it all together. Now this is BriForum. If you have a question, raise your hand and ask a question. But your question may be answered in 2 or 3 slides, because if you've ever read any of my articles, I'm very detailed and I'm very methodical in how I cover stuff. So if you have questions, ask, but I would rather you wait until we get after the putting it all together. Then if I haven't answered something, then we'll do some Q&A at that time. So from the basics, current server time. Webster, server time? Seriously? Yes. That is easily the number one thing, the first thing I find when I go to do an AD assessment is usually none of the servers have the right time, because you'll buy servers from IBM with Eastern time zone. You'll get servers from Dell with Central time zone. You'll get servers from HP with Pacific time zone. You put them all in the same data center and no one ever changes the time zone. And rarely do I ever see the PDC emulator configured properly to be the authoritative time server. So servers are always off on time. The current server time on your DNS server, and especially on the DNS server configured to be the scavenging server, is critical, because that is how DNS records get their timestamp, is the time that is on the DNS server where the record is registered. The resource record timestamp is going to show you, the date and time that the record was created. Now this time here, the 3 p.m., it always rounds down to the hour. So if this record had been created at 3:59:59, it would only show as 3 p.m. It always rounds down. Now by default, resource record timestamps are not shown, and that freaks some people out. No reason to freak out. Just go into your DNS Manager, click on View, click on Advanced, and then you'll see your resource record timestamp. Now by default, aging and scavenging is not enabled. So by default, resource record timestamps are of absolutely no importance because they are not replicated. Active Directory is smart enough to know that I don't need the resource record timestamp information if we're not going to age the records and scavenge the records. Now what about static IPs and static DNS records? This confuses some people. So a computer with a static IP is a computer that has a hard-coded IP address, but it is registered dynamically in DNS, and it gets the checkbox to delete this record when it becomes stale, and it gets a record timestamp, and then also the time to live is set for 20 minutes. A computer with a static DNS record is a record that you manually created in the DNS Manager console. It does not get the checkbox, delete this record when it becomes stale. It does not get a record timestamp, and its time to live is 1 hour. When you enable aging and scavenging, and you get everything configured properly, static DNS records are exempt from all the aging and scavenging processes. They will not be touched unless you screw up. Now, domain controllers. Domain controller DNS record. This is a computer with a static IP address that's dynamically registered in DNS. But domain controllers are special, very special, because you don't want anything of theirs in DNS screwed up. So they're treated differently. You'll see it's a computer with a static IP, but it's treated as a static DNS record. It does not get the checkbox delete this record. It does not get a record timestamp, and its time to live is 1 hour, which shows that it's actually a static DNS record. And if we go into the DNS Manager, you can see my 2 domain controllers. They have static IP addresses, but DNS treats them as static DNS records.
I mean, they have dynamic. You said they have
Well, when I configure a domain controller, I give it a static IP address.
Right.
And then it dynamically registers in DNS, but the console shows it as a static DNS record. Okay. Now, how can you screw things up? And this is what some people do. They say, hey, I found this command. Now, aging and scavenging. Scavenging is just a euphemism for deleting. And if Microsoft called it aging and deleting, people would freak out. You're going to delete stuff? No! So they call it aging and scavenging, and no one ever panics. So you find this command that says, hey, I'm going to age all records. So what you're telling DNS to do is to age and delete all records in DNS. And it will happily go out there and put a timestamp on every record and check the checkbox, delete this record when it becomes stale. And because most people's Active Directory is messed up, therefore replication is not working, domain controllers don't really talk to each other properly, the DNS servers don't talk to each other properly, and the next thing you know, you come in a couple of days and every record except domain controllers have been deleted out of DNS. So why not domain controllers? Well, when we go and look, my static DNS record now has the box flagged to delete it, and it now has a timestamp, meaning that, hey, I can now be used as calculated a time when this record is old enough and can be scavenged or deleted from DNS. Oh, sorry. Domain controllers. Domain controllers are special. It doesn't want you screwing them up. And I could not get a picture of it because it happened so fast. Even in my lab, when I had 7 2012 domain controllers, and I would sit there with the command prompt, age all records. Then I would sit there with the mouse ready to go and right-click my domain controller so I could look at the properties and look at the resource record timestamp and get a screenshot of it with the checkbox checked in that it had. I could never do it. It happened so fast on domain controllers. It doesn't want you screwing up domain controllers. So as soon as this was done, the domain controllers instantly fixed themselves and fixed their DNS records and made sure all their stuff was back in DNS, because it doesn't want you screwing around with domain controllers. The no refresh interval. The no refresh interval is a point in time that says, okay, here's when I was refreshed and here's when I can be refreshed again. During this 7 days, I will accept no refreshes for this record. I will accept updates. And I'll discuss the difference between a refresh and an update in 4 slides. I will not accept any refreshes. And there's a reason for that. If you're in an organization that has tens of thousands or hundreds of thousands of DNS records, if every record was refreshed constantly, how much traffic would your Active Directory database be getting? And every time that Active Directory database is hit and it's updated, all those changes had to be replicated around to all the other domain controllers and DNS servers. And so this is just Microsoft's attempt to kind of keep that replication traffic and the traffic to the Active Directory database down. And if you're using primary zones for DNS, it keeps the zone file from being updated all the time. The refresh interval. The refresh interval says, okay, all right, I can be refreshed, and then in 7 days, I'll be refreshed again. Now, by default, what is the DHCP lease time? 8 days. By default, what is the first DHCP lease renewal interval? 50%, or 4 days. By default, what's the second lease renewal interval? 87.5%. What is 87.5% of 8 days? 7 days. So by putting this at 7, we're saying, Microsoft is saying, we're going to give that DNS record 2 DHCP lease renewal time intervals to be refreshed. And then the start scavenging time. The start scavenging time says, this is the date and time that this zone can be scavenged. And it's done by looking at the current time, which should be accurate, on that DNS server or on the scavenging server, and then the same thing. It rounds down to the hour, so even if this were 2:59:59, it will show us 2. The scavenging period. This is the time interval that says a record is going to sit out there and be eligible to be scavenged, and at the end of this period, or 7 days, a process is going to run on the scavenging server that will go out there and look at every record in DNS and see which ones are eligible to be scavenged. Record refreshes. Refreshes generally occur for the following reasons. When the computer starts, the current name and IP is exactly equal to the previous name and IP. That's a refresh. During that 7-day no refresh period, this is going to be ignored. A periodic refresh is sent by the computer while it is running. Every 24 hours, every Windows computer, except for domain controllers, will refresh their DNS record. Every 24 hours. Which is why during that 7-day no refresh period, we don't want those records being refreshed every 24 hours. That's a lot of activity that would be happening. And they periodically refresh to make sure that if that record was accidentally deleted from DNS, it will put itself back automatically within 24 hours. Domain controllers will do it every 60 minutes. And then other network services can make refresh attempts. DHCP can make refresh attempts for the clients. The cluster service will attempt to make sure that the cluster service and the cluster records are refreshed in DNS. And then record updates. Updates occur for the following reasons. When a new computer is added to the network, it's going to send an update request to DNS to add that record into DNS. When a computer starts, if its current name and IP is not equal to the previous name and IP, that's an update. So if I go on vacation and I shut down my computer and then I'm gone and I come back and I turn my computer back on and someone else has gotten my old IP address, by default, when I start up, I'm going to tell the DHCP service that here's the last address I had, can I get it again? And it's going to say, no, you can't. Someone else has it. Here's your new IP address. That's an update. It will then update DNS with that information. And then the NetLogon service registers a new domain controller. And it will register all of its SRV records. Like we talked about last year, I do LDAP. Here's my port. I'm a global catalog server. Here's my port. I do Kerberos. Here's my port. All the other things that are available in your environment will be registered. Scavenging servers. This is an optional but highly recommended feature. Now, by default, Most people will right-click the properties of every DNS server and enable the box Enable Scavenging. Well, what you have done is you have enabled every DNS server to delete DNS records. So if you've got 8 DNS servers and every one of them is enabled for scavenging and something goes wrong, where do you look? You've got to go to 8 servers and 8 event logs to try and determine what went wrong in scavenging. By setting the scavenging server, by running this command, you're going to set 1 DNS server. Microsoft recommends 1 DNS server be set for scavenging. In a large distributed environment, Microsoft recommends 2. I've never seen Microsoft recommend more than 2. So if you take the recommendation to do just 1 and something goes wrong in the scavenging process, where do you look? On that 1 server. You've really narrowed down your troubleshooting. So when can scavenging start? The scavenging DNS server sets the time value to start scavenging on a per zone basis whenever one of these events occurs. Now, these events can actually be worded 2 ways, and I'm going to give you both wordings. When dynamic updates are enabled for the zone, it will set the start scavenging time. You can have everything else set, all the other checkboxes that you need for aging and scavenging, but if dynamic updates are not enabled, the start scavenging time will never be configured. And once you set this, the start scavenging time will be calculated. Enable automatic scavenging to stale records checkbox is applied on the scavenging server. You can have everything else set, but if this checkbox is not set, nothing happens. And once you get everything set, and once you check this checkbox and click apply, then it will go through and calculate the start scavenging time. If the DNS server loads a primary zone that is enabled to use scavenging, not everyone uses Active Directory Integrated DNS. Mark Manasseh in his classes tells people he doesn't use and he doesn't recommend his customers use Active Directory Integrated DNS. Why? I have no idea. I love Active Directory Integrated DNS. It works. I mean, it's just there. You don't have much to do. But you can use a primary zone, and I have seen customers that have greatly underpowered DNS servers, because remember, the DNS server keeps all those DNS records in an in-memory cache so that it can do your name resolution quickly. Well, many people will have a virtual DNS server with 1 vCPU, 1 gig of RAM, and they'll have a couple of 100,000 DNS records. And I've seen it where, for one client, it took over 6 hours to load the primary zone. So they could reboot that DNS server at 6 a.m., and it would be afternoon before that primary zone completed loading. And until that zone is fully loaded, the start scavenging time cannot be set. And once it finishes loading, the start scavenging time can then be set. When a zone resumes service after having been paused, this one puzzles me because I actually see people pausing their zones. Why they pause their DNS zones is beyond me. But if you pause the zone, it can't calculate the start scavenging time. And some people will pause it, and then they'll go out and set all the other checkboxes, and then they'll come back and start it. When you click start with all the other things set properly, the start scavenging time will then be set. If the zone is Active Directory integrated, you have to wait for replication to occur once. Why? Remember, Active Directory Smart, by default, aging and scavenging is not enabled. So by default, the resource record timestamps are not replicated. So no domain controller, if you're using AD integrated DNS, no domain controller knows anything about the aging of any DNS record, because none of them have the resource record timestamp. So once you start enabling all the settings for aging and scavenging, all those DNS resource record timestamps have to replicate around to all the other DNS servers and all the domain controllers. And then it has to do conflict resolution, because not everyone has accurate time, and most people don't have accurate time in their environment. So it says, okay, I'm the scavenging server, and I've got 5 entries for server 1. Which one is the most current? The one that's most current is the one I've got to keep. The other 4 I've got to get rid of because I can't use them in the aging and scavenging calculations. I have to use the most current. That's why time is very critical. It's the only way to accurately resolve the conflicts when you actually enable aging and scavenging. So when all the previous 5 events occur, the start scavenging time will be calculated by the current DNS server time plus the refresh interval equals the start scavenging time. So by default, it's going to take today's date plus 7 days, and that's when it will start the scavenging process. As I found out the hard way in doing my lab, but since I have no life, I created a lab with 7 2003 domain controllers, 7 2008 R2 domain controllers, and 7 2012 domain controllers. Created records, powered off computers, and let them sit for a month, eating up my electric bill, trying to follow this entire process. What happens at each of the 7-day intervals? What entries do I see in DNS? Well, I did the bad thing of setting automatic Windows updates on my domain controllers, and they all rebooted. And as I found out that if you restart the scavenging server, it resets the start scavenging time. So all my carefully calculated stuff to where I'd be able to get a screenshot on the second Tuesday of that month, shot, because every server rebooted. And then I was going through and trying to figure out some other things, and I realized that if you restart the DNS server service on the scavenging server, it recalculates the start scavenging time. And as I was reading some of the TechNet forum posts and some of the entries comments on blog articles and stuff where people discuss this, people say, hey, we got a nightly process because it's an in-memory cache. We go through and we have a scheduled process that goes through and restarts the DNS server service every night on all of our DNS servers. And scavenging never takes place. Well, duh, because when you start it, it says, okay, what is today's date plus the refresh interval, or if you're using the default 7 days, all right, I'm going to start scavenging here. The next night, you restart the scavenging or the DNS server service, and it says, okay, today's date plus 7 days is when I'm going to start scavenging. And then the next night, and then the next night, and scavenging just keeps being put off one day, and the scavenging process never runs, and people wonder why. I got all this configured and it's not working. Well, if you reboot, and some people actually have scheduled weekly reboots of their servers. If you do a weekly reboot of your DNS server that's configured for scavenging, scavenging is never going to run. And then you're going to be emailing me saying, man, I got all this, nothing's working. It's just nothing's being cleaned out of DNS. It's because these two, and these two are not well documented by Microsoft. This is one of these things you find out when you build labs and screw things up, which is why people like me have labs. All right, let's go through. How many people in here know Joe Schonk? No Joe Schonk? Oh, just a couple? Okay, well, I won't bother harassing Joe then. Well, what I did is on day 1, I created a virtual machine, just a Windows 7 virtual machine. I let it register in DNS, get all of its stuff set up, and then I just did a forced shutdown to kind of simulate what happens in a lot of desktop virtualization projects where people are working on their golden image and then they'll create it and then it doesn't boot right, or it never boots, and they just power it down, or they just force shut it down because it won't power up. and then they go and they then create another one, and they power that up, and that doesn't work, so they do a force shutdown, and they do it over and over again until they finally work out all the kinks in their golden image, and they get a VM that actually boots up. Well, what happens to all the DNS records for all of those VMs that you were playing around with? They're still in DNS. And so this was just to simulate, okay, how long will it take? Because that's one of the top questions I get. When I delete something, or if I delete a computer object, or I remove a computer, how long does it take until that thing is out of Active Directory? Well, this is how we're going to answer that question. So on day one, I create a record, force shut it down. First thing that happens, we have our 7-day no refresh period. So during this time, being shut off has absolutely no effect because it's not going to accept any refreshes at all. So if I'm on day 6 and I power back on that VM, the only thing that's going to happen is it's still going to be on day 6 because it says, well, you're within the 7-day no refresh. I'm not going to do anything. So the next one we get is our 7-day refresh period. Now during this time, it's going to wait 7 days for those two, by default, those two DHCP lease renewal time periods, the 4 days and the 7 days. So now we've gone 14 days. What would happen if I were to power up my VM on day 13? What happens is we go all the way back to day 1. And we start the whole process over again. I'm not going to accept any refreshes during this 7-day, and then we go back to the refresh period. So by being powered off, nothing has happened during these 14 days. Now we get into the scavenging period. The scavenging period says, okay, now at the end of these 7 days, I'm going to run a process, and I'm going to look at the current server, date and time, and I got this thing that says, hey, on the 21st of the month at 2 p.m., I can run the scavenging process. And it's going to process every record in DNS and says, hey, is this record, more than these 14 days in here? If it is, boom, I can scavenge it. Now, how can you tell if the scavenging process is run, what it has done, and when scavenging will run next? Well, you're going to look in the DNS server event log for event IDs 2502 and 2501. 2502 tells you that, hey, I have run and there was nothing for me to do, and I'm going to run again in 168 hours or 7 days. Then 2501 says, hey, I ran the scavenging process, but I didn't scavenge any nodes and I didn't scavenge any records. Now, because of my screw up, with the Windows updates and, restarting the DNS server service, I never got anything, but my friend Joe here sent me a screenshot from one of her customer sites that actually shows that, hey, this is 2008 R2, right? All right, I scavenged 7 nodes and I scavenged 7 records. Question, what nodes were scavenged? What records were scavenged? Have absolutely no idea. They're not put in the event. You don't know. Unless someone calls the help desk and says something's not working, then you go, oh, that must have been deleted from DNS. But right now there's no way of knowing. Even in Server 2012, doesn't put it in there. Now in the PDF, I found an article from a guy at Microsoft that tells you how to go through and do detailed auditing of your DNS zone records and how to enable auditing for deleted records and all of that. So you can try that to see if it will record what records were actually scavenged and what nodes were actually scavenged. But now once it's been deleted, is it really deleted? Not exactly. We're going to go take a look at the record in ADSI edit by connecting to the domain component domain DNS zones. So I bring up ADSI edit, DC domain DNS zones, websterlab.com. And then you're going to click on the domain DNS zones and then expand it. Then click on Microsoft DNS and expand it. And then click on my domain, websterslab.com. And then here's my record that was scavenged. I'm going to right-click that record, go to Properties, and I can see, if you're familiar with WINS, that DNS record has been tombstoned. So when that record is deleted, it is deleted instantly from the in-memory cache on the DNS server, and it is removed from the DNS Manager console. Because by setting the DNS tombstone true flag, it knows it should not be loaded, and the DNS Manager console knows that it should not be displayed. And now the record, and I realized this morning, I forgot to update the one screenshot, I forgot to update my presentation. But it's in the deleted containers object, deleted objects container, and since most people don't know the 27 steps to get into here, all of that's in the PDF, and you can go in there and actually look, and you can actually see all your DNS records that have been tombstoned. So now we have our DNS tombstone period, which by default is 7 days and can be changed by a registry key. So now once that record has been tombstoned, it's going to sit there for that 7 days. And then finally, the only thing that is not configurable in this entire process, at 2 a.m. the morning after our 7-day tombstone period, a process is going to run that's going to go out there and say, all the records that have been tombstoned for past the 7-day mark, you are now out of here. They are finally removed from the bowels of Active Directory. So from the time I created that VM, created the DNS record, shut down that computer, it is 29 days before that record is removed from Active Directory. Now, what if I'm in this tombstone period and I turn my computer back on? What would happen? Well, if you're running prior to 2008 R2 domain controllers or DNS, there's a bug. It's actually going to reanimate the object and create a new object. And it will do so continuously because it sees a tombstoned object, but yet it sees that I'm now live, so it attempts to reanimate. It will reanimate and then create a new one. Reanimate, create a new one continuously. And within just a matter of hours, your Active Directory database will grow to over 4 gig in size. So there is a hot fix for that. If you're running prior to 2008 R2, 2008 R2, 2012, have the fix already in there. It will see it and just reanimate it. Now, what happens if I bring up that computer and something is different on the computer, like a different owner for that DNS record? Prior to 2008 R2, you have the bug. It's going to reanimate it, but it's going to create a new one because the ownership has an issue in there, and it can't fix the ownership issue. 2008 R2, 2012, have that issue fixed, and they will actually, if there's an issue with the ownership, it will actually delete, just completely purge the tombstoned entry and create a complete new one for you. But wait, there's more. We're not finished. What about DHCP? And how does DHCP play into all this DNS stuff? The DHCP lease duration, as we talked about, by default is 8 days. First lease renewal interval is 50% or 4 days. The second is 87.5% or 7 days. And that's why all the defaults are set for 7 days, because Microsoft wants to make sure that we always get a chance to go through both DHCP lease renewal time intervals. By default, who owns the DNS record? The client. Prior to Vista, the DHCP client service registers the DNS record, whether DHCP is used or not. the DHCP client service. From Vista forward, the DNS client service will register the DNS record. But the client owns the A record. And if you're using DHCP, DHCP will own the pointer record. So Microsoft, their recommendation is that the no refresh and refresh intervals must be greater than the first DHCP lease renewal interval of 4 and less than the lease duration time. So the only time intervals we got are 5, 6, and 7. That's the only thing you can set right now. So if you go, matter of fact, I'm starting Tuesday on a project for a customer in San Francisco where they have the lease duration set to 4 hours. And they actually have the no refresh and refresh intervals set to 2 hours. And they had the scavenging period set to 1 hour. You should see their event logs. Nuts. And they have no idea why it was set that way. And they're wondering why they're having issues. So we're going to go in there and try and fix that. But if you change this, you are supposed to go in and change the no refresh and refresh intervals. So if you go and set this to 4 days, actually 3 days, because I've got a customer where we just fixed this. They actually, DHCP was set by the DHCP team and they will not change it. It's set to 3 days. So 50% of 3 days is 1.5. 87.5% of 3 days is 1.625. So about really the only option we had was 2. So we had to set our no refresh and refresh intervals to 2 days. And we had to set everything else to match that to 2 days. And why? They have no idea other than the DHCP team. It's always been that way and they're not changing it. So when you change the lease duration, you have other things you need to change. So by default, the client owns the DNS record. You don't want that. You want the DHCP service to own it. Now, Microsoft actually refers to this in 3 different ways. This is called the DHCP option 81. It's also referred to as DHCP DNS options, and in some articles, it's actually referred to as the DHCP client FQDN option. It's all referring to this tab. Microsoft recommended settings are you want DHCP to always dynamically update DNS A and pointer records. And you want DNS to automatically, to dynamically update the A and pointer records for old clients. Now, this also, according to the Microsoft documentation, covers Mac OS X, Linux, and Unix. And this is what Microsoft recommends that you do. Now, Server 2008 R2 and higher now have name protection. Name protection is to prevent squatting, name squatting. And this is not a Microsoft thing. On the server side, this is RFC 4701 and 4703, and on the client side, it's RFC 4362. And what this does, it creates a new resource record. It's a DHCID record, A and quad A, that will be put into DNS. And when you enable name protection, it will automatically do the preventing of the name squatting. And what preventing the name squatting means is if I've got a Windows server with IP address 192.168.1.1 and it's registered in DNS, and a non-Windows client boots up, say a Linux server, and it's also server 1 with an IP address that it's going to get from DHCP of 192.168.1.1 or whatever, it's going to see DHCP, because of this name protection, is going to see that, oh, there's already a Windows client that is registered for server 1 in DNS. You non-Windows box, I'll give you your IP address, but I'm not registering you in DNS because there's a superior Windows client already registered in DNS. And then once you set it, you'll see that it's grayed out the other options and set them to the Microsoft default. But now, we got a problem. What happens if DHCP1 is our DHCP server, and it is now registering all this stuff in DNS, and it dies? And we bring up DHCP2, and it starts handing out IP addresses. What happens when it attempts to update those DNS records?
Back up, I want to take a look here.
It can't. DHCP1 owns those records because it's the one that registered them in DNS. So what Microsoft says to do, no problem. Put those DHCP servers in the DNS update proxy group. And then all your servers will be in there, and the DNS update proxy group then becomes the owner of those DNS records. So that's what you're going to do. But what Microsoft gives on one hand, Microsoft takes away. The DNS update proxy group can only do unsecured dynamic updates. By default, your DNS server is configured for secure dynamic updates. So once you put the servers in that DNS update proxy group, they can't update DNS because all the DNS update proxy group can only do unsecured dynamic updates. So what's Microsoft want us to do? They want us to configure credentials for our DHCP server. And this can be a regular domain user account. And what you're going to do, right-click one of your protocols, IPv4 or IPv6, or you can do this on a zone specifically. And then go to the Advanced tab, click the Credentials button, and then just enter your credentials there. And then that will now allow the DNS update proxy group to do secure dynamic DNS updates. Now, when I did this at BriForum London, someone asked me, will this work with Server 2012's group managed service accounts? I didn't know, didn't test it. And I have tested it. It doesn't work. Like most things in Microsoft. They bring all these new features and most of their stuff does not work with group managed service accounts. So you cannot use group managed service accounts, and I've got the screenshots and everything in my notes in the PDF. So now, if you're going to use name protection, you must protect the DNS update proxy group. And Microsoft recommends that you do this even prior to 2008 R2 without name protection, that you protect the DNS update proxy group by running this command. And then that will go out and protect. Whew. That's a lot of stuff. So let's see if I can wrap all this up for us. So by default, DHCP lease is 8 days. First interval to renew is 50% or 4 days. Second is 87.5% or 7 days. By default, the client owns the DNS record, which you don't want. By default, everything is set to the 7 days, which allows us to go through both DHCP lease renewal time intervals. Microsoft recommends that you use DHCP and that you configure DHCP to dynamically register both Windows and non-Windows clients in DNS so that the DHCP servers can own those records. You put those servers in the DNS update proxy group, you add credentials so that the DNS update proxy group can then do secure dynamic updates, and then you protect that DNS update proxy group, and then therefore all your stuff is updated properly in DNS, and you set all your aging and scavenging stuff. You're going to have one scavenging server. You're going to set all your checkboxes. You're going to make sure you don't have any tasks that manually restart that DNS server service every night, and that you're not doing weekly reboots of at least that scavenging server, so that your scavenging processes will actually run and take place. Whew. Now, questions? That's a lot of information, and that's why a lot of people have issues with aging and scavenging. It's because there are so many intricacies, and if you change one thing, there are other things you're supposed to change. And all of this is like a cog and wheel. You change one thing and they're all interlocked together. Questions?
Do you ever see any issues with setting time servers to the Microsoft recommended NTDS5?
To the
Microsoft recommends setting time to NTDS5, so the domain sync for time. And we experienced issues with that. We actually had to
I always recommend using pooledidentity.org for your time servers. And so last year we talked about for America, I recommend north-america.pooledidentity.org, 0x1. Because if you don't do the 0x1, it doesn't take effect. And the latest article I just did on my website where I'm rebuilding my lab with all Hyper-V 3 and Server 2012, I actually show the group policy preference I created to actually configure the domain controller that holds the PDC emulator FSMO role as the authoritative time server, so that if you transfer that FSMO role to another server, just reboot it and boom, it's automatically configured. And some people wanted more detail, so when I get back home, I'm actually going to show how to do that from the GUI and also from PowerShell, how to configure that.
When you have multiple domains, do you still set up only one scavenger, or do you do one on each domain?
The scavenging will be, it's per server. That's a server setting. So if you have multiple zones, that server is going to scavenge all the zones that are on that server. That it is, obviously if it's a secondary zone, it can only scavenge if it's the primary zone resides on that scavenging server. Did that answer your question? Okay. Joe, you had one?
Yeah, in terms of the scavenging server, then what do you recommend for reboot interval?
For the scavenging, just the recommended once a month thing, but just realize that when you reboot that, it's going to reset the scavenging time. But you need to keep up with the Windows updates and the security fixes and stuff. But a lot of people actually reboot their domain controllers weekly. Or if they're DNS, they'll reboot them almost daily just to clean up the cache and stuff. So, which is not a good thing to do on the scavenging server.
Does the scavenging server need to be a domain controller?
If you're running AD integrated DNS, then yes. It must be. If you're using primary, it does not. If you're using primary and secondary zone, those can be any server. Any other questions on that? All right. For the second item, we're going to review what we did for single domain, single site. Then we'll cover single domain, multiple sites, multiple domain, multiple sites, and then we'll put it all together. So this is what we covered last year. This is probably what you see in 99% of Active Directory environments, because not every Active Directory environment is a large enterprise. You have a lot of mom and pop operations out there that are running like small business server or something like that, and there are a lot of small businesses out there that only need one forest, one domain, one site. And so what you do is you standardize. Active Directory really wants two things. It prefers simplicity. Now there are times when you have to be complex. Obviously, if you're the NSA or you're some big international corporation, you're not going to have a simple Active Directory environment. But beyond everything else, what Active Directory most desires is consistency. Pick something that you're going to do and be consistent in what you do and how you do it and why you do it. So what you're going to see here, these are just recommendations. What you do is specific to your environment, but be consistent, because when I go most places, there is absolutely no consistency to how any domain controller is configured for their IP settings. Absolutely none. So what you're going to do in just this simple environment, we're going to pick a domain controller. We're assuming Active Directory integrated DNS. You're going to pick a domain controller. I prefer the PDC emulator because it is the most equal of all domain controllers. In Active Directory, every domain controller is equal, but PDC emulator is more equal than the others because, as we discussed last year, when someone fat fingers their password, the authenticating domain controller doesn't know if that's the right password yet. The user may have changed it, so it has to go to the PDC emulator and ask, did the user change their password? No, it's the wrong password. When the user changes their password, the changed password immediately goes to the PDC emulator. If someone's account is locked out, it immediately goes to the PDC emulator. If you're running Server 2012 and you're running Hyper-V and you want to do the cloning of domain controllers, PDC emulator is what is used. Must be online or that process will not work. So you just pick one, and then all domain controllers, including the primary, point to it for primary. Then you pick another for secondary, and all domain controllers, including the secondary, point to it for secondary, and then they all point to themselves for loopback, for tertiary DNS. That's just the simple single domain, single site environment. So now what happens with multiple sites? Things are different. What you're going to do, every domain controller in the central site points to itself for primary, points to another domain controller for secondary, and then they all point back to loopback for tertiary. And then what happens when we add a remote site? The remote site will look to itself for primary, and then it will go back to the central site, any domain controller. I'm just pointing to DC1 because it's probably more than likely the PDC emulator, and point to it for secondary, could be any of the domain controllers, and then it will point to itself for tertiary. Now, the main problem I see with stuff like this is that you get this site and it's got one or maybe two domain controllers out there, it's got a few users, and either the site gets sold or it's not working right, so they send someone out there and someone out there just yanks cables, powers everything down, brings everything back, reformats everything. Or they just decide, you know, now we don't want to have domain controllers out there and our applications don't work with read-only domain controllers, so we're just going to bring everything back. And then what you've got are three orphans. You got orphan domain controllers in Active Directory. You now have an orphan site in Sites and Services. And you now have an orphan subnet in Sites and Services. And most people don't even think about that. And because most people never look in their event logs, they don't see the event log just screaming at them that you've got, this DC4, I can't reach it. It's my replication partner and I can't talk to it. You know, we haven't communicated in the last X number of days. This site says it's got domain controllers, but we can't, and so we're going to do automatic coverage. This site's now going to be covered by the domain controllers in the central site. And we got people with this IP address that are logging in, and they're told to go to this domain controller because that's the site for this IP address, and nothing's working. And then here we then have a remote site with multiple domain controllers. All those domain controllers are going to point to themselves for primary, back to a or some domain controller in the central site for secondary, and then in that site, because there are multiple domain controllers for secondary, they point to another domain controller in that site, and then you can either go back to the main site for tertiary, or you can use loopback for tertiary. And usually when you get a big site like that with many domain controllers in it, that's a site that usually has good connectivity, and that site will stay up and you don't worry about all the orphan stuff that happens usually when you have a single domain controller in a remote site. All right, multiple domains with multiple sites. Now we're going to make some assumptions. For this AD forest, we're going to assume that domain A is the first domain, so it's the root forest domain, and domain B was the second domain. I'm going to assume that this DCA-1A, that this is the root forest domain controller. It was the first one brought in, and it's the root forest PDC emulator. So what we're going to have for primary, all the domain controllers in their domain point to themselves for primary. They're going to point to another domain controller for secondary, and then yet another domain controller for tertiary in both of those domains. Now, why did I make such a big point about this? This is the only server in this environment that should be configured for time. This is the root forest PDC emulator. It is the authoritative time server for the forest. These domain controllers in domain A will look to each other or the PDC emulator to get their time. Over in domain B, I'm going to assume that this DCB1A is the PDC emulator for domain B. It should not be configured as a time server. The only one configured for time is here. The PDC emulator in domain B, other than these domain controllers over here, this is the only server domain controller in domain B that will ever reach out to the PDC emulator in domain A to get time. The other domain controllers over here will talk to each other, or they'll talk to this PDC emulator for time. If anything goes on wrong, then this PDC emulator will reach out over here and say, hey, something's gone wrong, I need some time, and it will get it. And if it can't, then that's when you start getting all the event log entries that I can't communicate with the authoritative time server, and I'm going to wait 1,672,542 seconds before I try again. I believe that's the time interval it sets. The other computers for domain A that are out here will use the domain hierarchy, and they will come to one of these domain controllers for their time. And the same thing over here. Our computers that are in domain B, they will come to these domain controllers for time. And there's, in the references that are in the PDF, I've got like over 90 references for all this information. But there's a very good article by Thomas Lee, one of the best Microsoft trainers in the world, that explains all of this and how the servers actually, there's an actual mathematical calculation that goes on how they determine which domain controller that they will hit for time. So now, if we add our first site over here, each domain controller in the site is going to point to itself for primary, and then it's going to point to another domain controller in that site for secondary, and then it's going to go back and point to another domain controller in the main site for tertiary, or you could use the local loopback. And then this is the same thing that will go on as you add multiple sites into there. And so it's the same thing. Once we add the second site, third site, fourth site, nothing really changes after that point. So now that you have all those sites, now what? Well, you want to create all your sites. How many sites should you create? As many as you need, but as few as possible. The site I'm going to work, or the AD environment I'm going to work on next week, they got 35 sites. One of them has domain controllers. And they're not using DFS. They're not using SharePoint. They don't have any remote servers. There's nothing in any of the other 34 sites. So I don't know why they have the other 34 sites. And then you're going to create the subnets, and then you're going to match them to a site. And then you can also create catch-all subnets and match them to a site. So you can actually create, if you know that the central site is going to handle everything that has a 10 dot IP address, you can create a subnet that says 10.0.0/8, and it'll be the central site. 172.16/12 will handle site 2, and 192.168/16 will handle site 3. So that way, if your network infrastructure team, or they go out and buy the 4th floor of a building and add that in, and as always, or almost always, the AD team never knows about this stuff. But the router guys, the firewall guys, the content filtering and all that stuff, they know about all the new IP addresses and the new subnets that are going to be added. The AD guys don't know. So if we create these catch-all, we'll catch if something comes in as 10.4. whatever and we don't know about it, that 10.4 is going to be caught by the catch-all and will automatically be handled by the central site. And then because I know that you are doing weekly monitoring of those netlogon.log files in the C Windows debug folder on every one of your domain controllers, you will notice that on the day that you go out and look at that file, you will see that, oh, I've got all of these out there coming in from 10.4. So you will then go out there and create a specific subnet that says, hey, 10.4, whatever, goes to the central site. Because it will always use the most specific. So if you already have a 10.4 and they add a 10.4, it will match it. If you got it, then they add a 10.5, that catch-all will then catch it. And then you're going to create site links. This is the thing that most people miss. They create all these sites, and as smart as Active Directory is, and as smart as the knowledge consistency checker is, it knows absolutely nothing about your LAN or WAN topology. You have to tell the KCC how the sites are connected so it can create a replication topology. If you don't, you get issues. Things don't replicate, and then people go out and they create manual connection objects, which is a bad thing. That's one of the things we talked about we're not going to have. And then what you can do is then you can say, okay, to go from central site to site 2, I got a direct link. From central site to site 3, I've got a direct link. Now, in case of an emergency, I do have a link from site 2 to site 3 that we could use. But I really don't want you using it for normal replication or anything else because it's an expensive link. When we use it, we have to pay. So it knows that when it creates the replication topology, that it can go from central site to site 2, central site to site 3. So if it has to go from site 2 to site 3, it'll go from site 2 up to the central site down to site 3. If it loses that link from site 2 to site 3, it knows, okay, now I can use that link from site 2 to site 3, but only in a last-ditch effort. And then you're going to place your servers in the appropriate sites. If you have all of this done beforehand, before you start creating, bringing up domain controllers, the domain controllers will automatically place themselves in the correct site. And in Server 2012, you can now, as part of the domain controller promotion process, actually tell it what site it should go to. And now we're going to sit back and let the KCC do its job and stay out of its way. How? Great question. Glad you asked. We're going to do that by checking our domain enforced functional levels and getting off of those old things so we can use more efficient replication and topology generation. We're going to make sure all domain controllers are global catalog servers so our users have an optimal login experience. We're going to make sure there are no manually created connection objects in sites and services. If you ever see a manual created connection object in sites and services, that's a bad thing, delete it. We're going to check that netlogon.log file on all domain controllers. Every week, we're going to check it for missing subnets. And when you find those missing subnets, you're going to create reverse DNS lookup zones for all those subnets and sites and services. And then we're also going to clean up DNS of unnecessary duplicate host names and IP addresses now that you know how to properly do aging and scavenging. And we're going to clean up orphan domain controllers because you're going to be checking those system event logs on your domain controllers and see that they are screaming to you that stuff is out there that shouldn't be out there. You're going to make sure the PDC emulator is configured properly to be the authoritative time server for the forest, because as you've seen for DNS, it is critical that time is accurate. And then we're going to make sure all domain controllers have their DNS IP settings configured properly. And we're going to use Microsoft and other vendors' Active Directory design guidelines. And once you got all these things done, your users will be happy they'll have much better logon experiences. And when they have good logon experiences, they're not complaining. And then your Active Directory projects and your desktop and application virtualization projects will just have smooth sailing. Questions? One thing I do want to bring up, the myth of Kerberos time. When you use W32 time, the only thing Microsoft guarantees with its time service is that it's accurate enough for Kerberos to work. The other myth, if my computer is more than 5 minutes off from my domain controller, I can't log in. That's not true. The RFC just says it should not log you in. And if you're familiar with RFC language, should doesn't mean must. So Microsoft allows authentication. Domain controllers are different. If domain controller 1 is off by 6 minutes from domain controller 2, those two domain controllers will not talk. They don't know about each other. They will not talk to each other. They will not replicate until time is fixed on the domain controllers. Your users are oblivious to all this going on. All right, so now, before you leave, hopefully I got my time done right. This is now live. There's the, whatever you call that little black and white thing up there. You can click on it and it'll take you right to the link. And we've got 3 minutes left in case there's anyone have any questions on any of this stuff? All right, well, thank you very much.